Hey, let's talk about polar coordinates today. So polar coordinates you probably haven't seen before. And the polar coordinate system is kind of like the idea of describing something on a coordinate grid, but instead of a grid, these look kind of like concentric circles. But let's start with, to form the polar coordinate system in a plane, we're going to fix a point O called the pole or the origin. So the pole would be kind of like the center. From O on an initial ray called the polar axis. Then each point P in the plane can be assigned polar coordinates. And we call those r, comma, theta. So instead of x, comma, y that we're used to, we call these r, comma, theta. R is the distance from your origin or your pole to the point P, and theta is the angle that we count counterclockwise, which is the same as what we've used to counterclockwise. And in the system, points do not have a unique representation. So let's go back and talk about what a polar coordinate grid is. So we kind of have this axis. A circle like this would be the first distance of 1 from this is our origin or our pole. So this distance is here is a distance of 1, where we would call that a radius of 1. The second one we'd call a radius of 2, which would be r equals 2 away from the pole. This next one we'd call a radius of 3, which would be an r of 3 from the pole as well. And we use an angle to kind of calculate where this might be. So for example, I know that 90 degrees, maybe use it black, 90 degrees is right here. So this point on the grid we'd call r is 1, comma, theta would be 90 degrees, or we could call that 1, comma, pi over 2, because that's the same as 90 degrees. If I wanted to find this point right here, we'd call this point r is 2, because it's a radius of 2 from the pole on that same angle, pi over 2. And then this last one here, we would call that r is 3 away from the pole, and it's along the ray of pi over 2. So we can use this idea to describe where it is on the grid or on the polar coordinate system. So in the system, points do not have a unique representation. For example, the point r, comma, theta can be represented as r, comma, theta plus or minus 2 pi n, which just means any coterminal angle with that original theta. Or you could even say that it's negative r from theta plus or minus 2 n plus 1 times pi. Here's what that means. If we're using negative r, that's like the other side of the circle. So you would add another pi to the theta. So I'll tell you about that in just a second. So basically theta could be any angle when the pole is 0, comma, theta. Okay, so for this example, we're going to plot r, comma, theta, where r is negative 2 and theta is 11 pi over 4. So let's find 11 pi over 4. Well, I know this is 0, 0, pi over 2, pi, and 3 pi over 2. And then back here would be also 2 pi. So if I want to look for 11 pi over 4, I'm going to kind of visually cut this. This is pi over 4. Here's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and then we go back to another 9 pi over 4, 10 pi over 4. Here's 11 pi over 4. It's right along this line. So here's the deal. When they say, if they said positive 2 comma 11 pi over 4, that's when r is 2. So from the origin or our pole, we'd go 1, 2 away. So this right here would be 2 comma 11 pi over 4. Well, when they say negative 2, we're going to go the opposite direction. So along 11 pi over 4, we're going to go past the pole and go negative 1, negative 2. So this is our negative 2 comma 11 pi over 4. Okay, what if we were given this point 4 comma pi over 6, and we wanted to find another representation of that point? Well, I know pi over 6 is along right here, and if I had 4 is saying it's 1, 2, 3, 4 units along from the a radius of 4 from that circle. So that's this point right here, 4 comma pi over 6. So what else could we do to name that same angle? So number one is we could change theta and just add another 2 pi n. So meaning circles either way around. So I could call this 4 comma, if I added another full circle plus 2 pi, that would be 13 pi over 6. I could go the other direction and go a negative circle. So I could go 4 comma negative 11 pi over 6. I could also extend this angle right here, which I know is 7 pi over 6, and say I want to go negative 4. So remember, negative 4 along 7 pi over 6 would be 1, 2, 3, 4 this way. So I could say negative 4 comma 7 pi over 6. Those are all different ways that we could graph another polar representation of the same point. The same idea as coterminal, and we could also have an infinite number more. Okay, next page. Let's talk about how to convert from polar coordinates to those rectangular coordinates that we're used to. Okay, so x in the rectangular coordinate system is equal to r times the cosine of what theta is. Y equals r times the sine of what theta is. We can also break down tangent theta equals y over x from the rectangular to tangent theta. And we also know that r squared equals x squared plus y squared. Okay, we're going to use those 4 things here to convert back and forth. So to convert polar coordinates, so remember polar means r comma theta, to rectangular coordinates are x comma y. So we want to go from r comma theta to x comma y. So what are we going to do with that? So what we know is right now is that r is 3 and that 3 pi over 2 is theta. So that's what we have. What we want is we want x and y. So what we know is that x right here is r cosine theta. So to find x, I'm going to say r, which is 3. So r times the cosine of theta is really 3 times the cosine of, specifically this time, theta is 3 pi over 2. Now remember, 3 pi over 2 is right here. So here's 1 pi over 2, 2 pi over, here's 3 pi over 2. That's a 270-degree angle. That point right there on a rectangular coordinate grid is 0 comma negative 1, which remember is cosine sine. So the cosine of 3 pi over 2 is 0. So that is really 3 times 0, which is just 0. So x is 0. Y equals r sine theta, which I know r is still 3 times the sine of our theta is 3 pi over 2. Well, I know sine at 3 pi over 2 is negative 1. So we're going to say that's 3 times the sine of 3 pi over 2 is -1. Well, 3 times -1 is -3. So that conversion from r comma theta to x comma y is going to be 0 comma -3. Okay, and then we're not going to work on equation conversions right now. All right, I'll see you back in class. Thank you.